Coding Samvaad.
Combination sums. Let's analyze this problem. In this problem, we have been given a candidate list, that is 2, 3, 6, 7. They have also given the target, that is 7. We need to form the combinations from this candidate list such that their sum is equal to the 7. How? In the output you can observe that the first subset is 2, 2 and 3, and they are sum to 7. Similarly, the second subset in the output is 7, which is also 7. So we need to generate all those combinations that sums to the target. And they have said one line that any number, we can choose an unlimited number of time. That means you can observe in the output that 2 has been chosen 2 times. So there is no such limit that you have to choose a number only one time. You can choose it any number of time. The concept is simple. That is, we will be focusing on including any element with other element or not including that element. Suppose initially we have chosen an element from this array. Let's say it is 2. Now we will be making its combination with other elements that has been present in this candidate list. It is similar to subset problem. But the only condition that differs here is that we can choose any element from this array unlimited number of times. If you have 2 initially, then you have the choice whether you need to choose 3 or you don't have to choose 3. And the second condition that is here is that you can choose to any number of time. Suppose initially it was 2, then again you can choose 2. And since you have chosen 2 here, so it will become 2 in the subset. For better understanding, we will be focusing now on recursion tree for this problem. Let's consider that initially we are having an empty vector and another vector of vector, that is result, which will store the result and that will return the result to the main function. Now I will be selecting one element from this candidate array. Suppose that is 2. And in the concept, I will be looping through all these elements. And while looping, I will take care of that if I am selecting any element, then I will be making its combination with other and itself, until and unless I am not getting my target. This question also uses the concept of backtracking, because at the end we need to generate all type of combinations. And whenever we have choice and we need to generate all type of combinations, that means backtracking. Choice means recursion, and number of combinations when required to generate, that means backtracking will be used. You suppose you have chosen 2. That means your new vector will become 2 because it will store it. Now after this, you have the choice whether to choose the 2 again. You have the choice whether to choose the 2 again or choose the next elements. So I will be choosing the 2 again. Let's also focus on the target. We have been given that the target value should be 7. So initially the target value here was 7. And now after adding 2 to this vector, the target value will become 7 minus 2. That is 5. Now if I am choosing 2 again, it means my vector now will be becoming 2 and 2. And the target will become 5 minus 2. That is 3. After this, I will be choosing the 2 again. Kindly note that this choosing process is actually you are diving into the recursive calls. These are the recursive calls that have been made after you have selected this position. Initially, you selected this position and you are recursively traversing now to dive deep into the recursive tree for your target. Therefore, now your vector will become this, and you will be subtracting 3 minus 2. After this position, you find that your target now has become 1. Your target now has become 1, that is this. Now, if you choose 2 again, you will reach to 1 minus 2, that is minus 1. It implies that you are reaching lesser than the target. This is your not target. This is not the target. Then what to do now? At this position, at this position, we came to the conclusion that we are actually getting onto the base condition. So from here we came to the base condition and we thought and examined it that the base condition in which you are not reaching the target, rather you are getting to the negative of the target, it means you will be simply returning from that position. So here you will be returning the call at this position. You will not be calling anything now. So the call will return back. Actually, you are backtracking here. You are backtracking here and you are returning back to search for the actual target. While backtracking, while backtracking, while backtracking, you need to take care in mind that as you backtrack, you pop up the last element from the vector to update your vector. Because here you can observe that the count of 2 was 4 here total. Now when you backtrack, you will remove the 2, and now your count of 2 will become 3. And when you backtrack, here also the count of 2 will become 2 because you have removed 1 2 here. Now we are at this position. When you have the target value as 3, therefore you will be now choosing the next element. You will say that my choice for choosing the 2 was wrong because I am getting to the target that is not actual target. So you will be now choosing element 3. Now you will be choosing element 3 from here, and you choose element 3. When you choose this element 3, now the vector would become 2 2 and 3, and the target that was earlier 3 and the target that was earlier 3 now will become 3 minus 3. And this 3 minus 3, that is 0. That means if the target is 0, hence we can say that again we are reaching a base condition that was required. Again we are reaching a base condition that was required. The base condition is that as soon as our target is becoming 0, in that case we will be pushing our vector into the result vector. So we will be pushing 2 2 and 3 into our result vector, and definitely after pushing we will be returning from here. Let me write the base condition, the second base condition that let me also write the second base condition that we received earlier. That was if your target value becomes lesser than the 0, in that case you will be simply returning the call. So this is our second base condition. This is our first base condition. Hence, after coming on to the base condition, we will be updating our result vector. That is 2, 2 and 3 is a combination that we have got. Now we will be backtracking again from here. We will be returning to explore it further. We have explored this. Now at this position, we will try to explore it for 6 and 7. If I include 6 here, then it will become 2, 2 and 6. But my target would become, that was earlier 3, that will go in negative. that will become minus 3. That means we need to return through the base condition second. We will simply be returning back. We will simply be returning back from here. The same case would be for 7 also. The same case would be for 7 also. We will be returning back. Now, the call will return back to this position. The call will return back to this position now, where you have target value as 5. And we will be exploring this. Let me write the vector again here. It was 2, 3, 6, 7. And currently we are standing at position 2 here. And now we are trying to explore when our target is 5. And we have chosen the value. Now, while standing at position 2, now I will be exploring the next value. That is 3, because I have already explored the value 2 itself. And there we have got this subset. In that core recursive calls, I have able to achieve this subset. Now I will be exploring for this. So we have chosen 3 now. Now the vector will become 2 and 3. And our target vector will become, and the target would become 5 minus 3. That is 2. Now after this position, you have the choice to explore for 3 again or choose any other element. So let's explore for 3 again, and we will find that if I explore with 3 again, the target would become negative. The target would become negative. What? That is 2 minus 3. That is minus 1. So when the target will become negative, we know we will be returning back the call through the base condition 2. So let's return back. We return the call back. Now again we are at this position. While at this position, we will be exploring for other elements. Now you will explore for 6. So when you will explore for 6, you will find that again the target would become negative. And when the target would become negative, you will return back. You will again backtrack. Now the same case would lie for 7. If you choose 7, you will end up in getting the target negative. Therefore, you will backtrack. It means in this position, you will not be getting any subset. You will not be getting any subset which sums. You will not be getting the subset that sums up to the target. You will be now backtracking again here, and you are again on this position. Now from this position also you will backtrack to our main position from where we have started this journey. So again we are on our same position. Now since I have said in start of this traversing that we are actually traversing through loop, we are actually traversing this candidate array through the loop. Loop is being used for selecting and considering every element of this array. But after selecting one element from this array, we are diving into combinations with other elements through recursion. So this overall call that we have, this overall call that you are watching on your screen currently was only for element 2. These were the combinations that was being made when you have selected element 2 in the loop. Now we will have the calls for second element, because it was I equals to 0 when you were selecting for 2. Now you will be selecting for I equals to 1, and you will be starting the loop now for element 3. Now you will be starting the loop for element 3, and you will be making combinations with either 3 or other element, that is 6 and 7. It is quite messy, but you need to understand this tricky solution. For better clarity, I will be making the diagram again for 3. So as I have said that initially, as I have said that we again reach to the condition when our vector is empty and the target is 7. But what the changes that have occurred till now was that we was able to get one subset that was 2, 2 and 3. And this we got in the earlier recursive calls that you have seen when you selected the value 2 and made the combinations with other elements. Now we will be exploring all the combinations that are associated with element 3. So you are here initially, your loops stand here. Now you will be recursively diving into other elements. If I am exploring 3, the combination will become 3 and the target would reduce to 4. Now I will again explore for 3. The combination will become 3, 3 and the target would reduce to 1. Again I will explore for it. It will become 3, 3 and 3 and the target would become minus 2. At this position we got the target negative, so we will return back. We will backtrack. Now at this position we will try to find other choices. How? We will check for 6, we will check for 7. So if I include 6, then it will become 3, 3 and 6, but the target would become negative, so we will be backtrack and we will now explore for 7. Similarly, we will here also get the target negative, so we will backtrack. Now we will backtrack here. At this position, we can find that when we will explore for 6 and 7, we will get the negative target. Therefore, we will be backtracking from here also and we will again come on to the position when the target is 7. Therefore, we will be now exploring all the combinations that are associated with 6. We will now be exploring all the combinations that are associated with 6. We will be exploring 6 with 6 and its other elements. If I take 6, the combination would become 6 and the target would become 1. After this, I will again go for 6. So when I will go for 6, I will get the target as negative. Therefore, I will backtrack. And when I will backtrack, I will come to this position again. Now I will check for other choice, that is 7. I will try to make combination with 7. So when I will make combination with 7, the target would again become negative. And when it will become negative, so I will backtrack. Therefore, again, I didn't get any combination, valid combination. I will backtrack. At this position, now I again came to the position when the target was 7. Therefore, now it's time for exploring all the combinations that are associated with 7. So 7 will be explored with 7 only, since there is no any other element left. Therefore, 7 will be explored with 7 only. So I am taking 7, and when I take 7, my subset would become, my combination would become 7 and the target would become 0. So as you know that if the target is 0, again you are reaching the base condition and you are getting a valid combination. You are getting a valid combination. It is a valid combination. Therefore, you will be including it in your result.
It's time for recap now. You can just have a read. So we have been given a function combination sum, which is accepting candidates and target as an input. Therefore, we have defined result, which is a vector of vector, since we need to return a vector of vector. And then we have also defined a vector that is current. To generate a combination, we have defined current, which will help us to generate the combinations. And we have this solve function, which is accepting candidate, target, and 0 as an index, initial index, current, and the result. After exploring all the combinations and recursive calls, we will be finally returning the result, which includes all the combinations. Now let's discuss the solve function. It is the function that we have defined. It accepts two base conditions. These are the two base conditions. The first condition is when your target is 0. If target becomes 0, so add it to the result. As if if target is negative, that is less than 0, in that case the current combination is invalid, so you will be directly returning from here. It's time to discuss now recursive case. In recursive case, we are using the for loop for selecting each element of the candidate array, and then we are adding the candidate in the current vector. It is basically the inclusion operation. It means that we are choosing that element, we are choosing the candidate and including that in the current. We are then calling the solve function recursively and exploring the depth for the chosen candidate through the loop. We will recursively now dive into the depth for exploring all the combinations that are associated with that chosen element. We are recursively exploring the choices. After calls are over, we are coming on to the current.pop back. Here we are actually excluding. It is the exclude operation which we are tackling during the backtracking. We are actually removing the last chosen candidate. One thing that might be worrying you is that this solve function. What is this? In the solve function, we are actually updating the target by reducing the candidate that we have included in our current vector. And the other thing is that why you are not changing the index, why you are not updating it. It is because it has already been defined in the question that you can choose a particular element from the candidate unlimited number of times. Therefore, I am not changing the index here. It will be automatically changed as you will explore the choices and you will backtrack. Now I think it will not worry you. Thank you for watching this video.
Like, comment, subscribe to Coding Samvaad.